myself Ketan Nausar, Assistant Professor in LG Engineering College, Ahmedabad. In today's session in embedded system, we discuss about counter and counting devices from chapter number 2, device and communication buses. So now we go ahead and we discuss about what exactly the timer and counter devices is. So now timer and counter. I hope that you already know this word before and you already heard this word before because this word is very popular, right? In digital electronics, you also learn counters, like different types of counter that you learn like up counter, down counter, ring counter, junction counter, right? And also in terms of the microprocessor and microcontroller, you already know this word like timers and counters. So now first of all, we discuss about timer. What is timer? A timer is a sophisticated type of clock which is used to measure the time interval. Means if you want to calculate or measure the time intervals, then we have to go with the timer. A timer that counts from 0 upward for measuring the time eclipse is often called a stopwatches. You can see your best example of your timer is your stopwatch. It counts specific time intervals from the initial value 0. So it is a device that counts down from a specific time interval and used to generate a time delay. Fine. So there are the number of examples that we are knowing what exactly the timer is, but the main thing is that when you're talking about the timer, then we have to take care to measure the time interval only. If you know how to measure the time interval, then definitely you are getting the idea that what exactly timer is. Okay. So now we go and discuss about counter. What is counter? So counter is a device that stores the number of times a particular event or process occurred with respect to the clock signal. If you want to measure any type of ingredients or any type of the things are passing from one place to the another places, then counter is generally used. It generally use a clock pulses. If you visit any industry, like suppose if you visit some food industry, fine. So ready-made packet is generally passing from one place to the another place. So how many packages is passing from one place to the another place, that you can count using a counter. Even in bank you see right now in some commercial banking and private banking, they have put a counter in front of their desk. So whenever you enter, you have to take one token number, and if your token number match with a display, then you have to visit that particular counter. So basically, counter is very popular when you have to calculate any type of objects is passing from one place to the another places, right? So any process is generally occur. So it is used to count the event happening outside the microcontroller. Okay. So in electronics, the counter can be implemented quite easily using the resistor type circuits such as a flip-flop, because it can use to store the data. Fine. If we have to count down the value from 1 to 10, then ultimately if count is equal to 1, then count is equal to 2, then we have to store the 1 in somewhere. So you have to use a resistor. Fine. You can go with the D flip-flop, you can go with the JK flip-flop, you can go with the SR flip-flop. So these are the basic what exactly timer and counter is. Now we're talking about the differences, what exactly the difference between timer and counter. So you can see in timer the resistor incremented for every machine cycle. The resistor is incremented in every machine cycle. In counter, the resistor is incremented considering 1 to 0 transistor at its corresponding to the external input pins. Means here you can see the machine cycle is always updated with respect to the specific increment, and here only the transaction is going on from 1 to 0 for external event. A maximum count rate is 1 divided by 12 of oscillator frequency. Definitely you have to divide from 1 divided by 12. And in terms of the count, you can divide it by 24. So a timer uses the frequency of the internal clock and generator delay. The counter uses external signal and count the pulses. Fine. So basically, here you can see the timer is only work in terms of the internal clock mechanism, and counter is only work in terms of the external clock mechanism. So these are the basic difference between timer and counter circuits. Now we go ahead and discuss about some different types of clock. Like in our syllabus, we have to discuss about real-time clock, watchdog timer. Fine. So now we go what exactly the real-time clock is. So real-time clock is considered as a RTC. It's a real-time clock, and RTC is right now available in each and every electronic devices. Like if you're talking about the laptop, palm top, computers, smartphone, even in smartwatches. Now the RTC is each and everywhere. What is RTC? Now we go and discuss what exactly the meaning of RTC is. So RTC is an electronic device that measures the pass of time. Although the term often referred to as a devices in personal computers, servers, and embedded systems. When you disconnect the power, it takes the supply from the CMOS cell and it operates when there is no power supply is available. So RTC chip containing the microchip for holding the time and data related informations and battery cells for function in absence of power supply in single integrated package. So right now RTC is very popular because it takes a very small amount of time, and the main advantage of RTC is that it makes your time very accurate. I give you a simple example of your smartphone. If you switch off your smartphone for 1 hour, suppose if you switch off your smartphone on 11:30, and if you turn on your smartphone after 1 hour, so ultimately you can see the time is automatically updated over there, and you can see it's at 12:30 in your smartphone. How it is possible? Because it is possible only because of the RTC. It's a real-time clock is there. So here you can see the few example, or we can see the few element devices or chip available. We can use as a RTC, and as I already told you, you can see we are using here CMOS cell. Why we are using here CMOS cell? Because when there is no supply is available at that same time, it will take a power supply from the CMOS cell and it make your device accurately. It will make your device time accurately. So this is the basic difference between timer, counter, and RTC based circuits. Right? I hope that you are getting idea what exactly I am trying to convey. Now watchdog timer. Now what is watchdog timer? A watchdog is a monitor the framework execution and reset the system processor and controller when the program execution hang up or generate an interrupt in case the execution time for task is exceeding the maximum allowed limit. If the firmware execution does not complete due to the malfunctioning within the time required by the watchdog to reach the maximum count, the counter will generate a reset pulse, and this will reset your processor. If some uneven type of activity, or we can say that some unknown pulse is entering in the system, so for providing the safety and security, the watchdog timer is used to, it reset your circuit. If it resets your circuit, then ultimately your circuit starts from the beginning. So some malfunctioning, some unwanted signal will release at that time. So it's called as a watchdog timer. I give you a simple example of the watchdog timer in your ATM machine. If you see that once you are entered in ATM machine, if you hold your card or if you insert your card inside the ATM machine, it will give you some round of time. If you not press within some certain amount of time on the specific display screen, then ultimately it will reset automatically on specific time interval. So this one is the best example of the watchdog timer. Fine. So most of the processors implement the watchdog as an inbuilt component and provide the status register to control the watchdog timer, because right now the technology is going on. VLSI technology is increasing day by day. So as you can see, because of VLSI technology, right now the watchdog timer is also providing inbuilt mechanism inside the chip. So here you can see the pre-running counter, reset pin, system clock, and watchdog timer. So what exactly the role of watchdog timer? It will match with a reset pin. If the counter reaches to the maximum limit, then ultimately it will trigger or provide the pulse to the reset pin, and reset pin is generally reset your whole microcontroller and microprocessor. Brownout reset. What is brownout reset? So brownout is, it's a popular word, but we are not using till that. We are already discussed about the real RTC, watchdog timers, different types of counters. But what is brownout reset? The brownout reset is provide the protection circuit to prevent the processor and controller from unexpected program execution behavior when a supply voltage to the processor and controller fall below a specific voltages. I give you one simple example of your brownout reset. Like suppose, assume that if you are using the node MCU microcontroller and it requires 3.3 volt minimum to generate or to the LED turn on or to provide a specific or to execute a specific task. But if you are not able to provide the specific amount of voltages, then your task will be not executed or your task will be not executed at that same time. So that particular time moment is called as a brownout reset. Brownout protection circuit prevent the processor and controller from unexpected program execution behavior when supply voltage to the processor and controller falls below a specific voltage. It's called as a brownout reset. So thank you very much for this session, and I hope that you are getting the idea of what exactly I am trying to convey in terms of a real-time clock, watchdog timer, brownout reset, and also we discuss about the difference between timer and counter. If you have any doubt which is related to the timer, counter, then you can feel free to contact me. So the main difference is very clear. When you're talking about the timer, then ultimately you have to discuss about the time interval which is going on, and we have to calculate the time. One of the best example of timer is your stopwatch. When you're talking about the counter, then you have to calculate the specific event is going on in terms of the counter side. And for the specific event going on the counter side, we have to count the specific type of object, specific type of ingredients which is going on. So one of the best example you can see in each and every industry, even in the bank, the counter is there, right? And then the RTC means a real-time clock. The DS1307 is one of the most popular RTC. Right now we are using in microcontroller, like you can interface with Arduino, you can interface with Node MCU, you can interface with 8051. Fine. And then also we discuss about the other types of watchdog timers and a prescaler based circuits. So I hope that you are getting the idea of what exactly I am trying to convey. If you have any doubt, still then you can feel free to contact me. So thank you for watching.